Imagine standing in a vast library filled with millions of books stacked from floor to ceiling. At first glance, this might seem like paradise, every piece of information you could ever need right at your fingertips. But as you start looking for a specific answer, say the cure for a rare disease or the key to a new technology, you quickly realize that the abundance of information makes it nearly impossible to find what truly matters. This is the heart of the information paradox. The more information we gather, the harder it becomes to extract clear, meaningful knowledge. We live in an age of data abundance. Every day, humans generate around 328 million terabytes of data. Social media posts, scientific papers, emails, videos, sensor readings, and more. In theory, more data should mean more insights, better decisions, and faster progress. But in practice, too much information often leads to overload. Our brains and even our most advanced AI algorithms can become overwhelmed, struggling to filter noise from signal. Have you ever felt more confused after Googling your symptoms than before? That is a small-scale version of this paradox in action. A striking example of this problem is found in medical diagnostics. Doctors now have access to vast amounts of data: genetic sequences, imaging scans, blood markers, wearable devices. While each piece offers valuable clues, the sheer volume can create conflicting signals or lead to overfitting, seeing patterns that do not actually exist. In a similar way, investors drown in financial data, students get lost in research papers, and policymakers freeze under conflicting expert reports. The result? Paralysis by analysis, more data, yet less clear guidance. Why does this happen? One reason is that information is not the same as knowledge. Information is raw and unfiltered, like puzzle pieces scattered on a table. Knowledge is the picture that emerges when you put those pieces together in the right way. As we collect more and more data, the challenge shifts from gathering to curating and interpreting. How do we decide which data points are trustworthy, which ones are relevant, which ones point to deeper truths? Without careful filtering, context, and synthesis, the pieces never assemble into a coherent picture. This paradox sparks an important question. Can technology help us overcome information overload? Tools like AI-powered search engines, machine learning algorithms, and data visualizations are designed to sift through massive data sets and highlight key insights. But even these tools depend on human judgment and often introduce their own biases. A poorly trained algorithm might highlight popular but incorrect results, amplifying misinformation rather than clarifying it. Ultimately, the information paradox teaches us a humbling lesson. More data does not guarantee more wisdom. In fact, it can create a fog that obscures it. To turn information into knowledge, we need better systems for filtering, critical thinking skills, and a renewed focus on asking the right questions rather than merely collecting answers. It reminds us that in our quest for understanding, quality and not sheer quantity remains the true key to progress. The information paradox refers to the observation that beyond a certain point, more data can hinder rather than help decision-making. While information theoretically increases certainty, in practice, excessive information overwhelms cognitive and computational capacity. Human brains evolved to handle limited, contextually relevant inputs, not vast, unfiltered streams. The cognitive load from excessive data leads to confusion, reduced focus, and analysis paralysis. As a result, knowledge extraction efficiency diminishes when data volume surpasses processing capability. A doctor overwhelmed with hundreds of test results may struggle to identify the single critical indicator of disease. It is like trying to hear a single violin in a stadium filled with 1,000 noisy instruments playing at once. Human working memory has a limited capacity estimated at about 47 discrete items. When too much information is presented, individuals cannot effectively encode, process, or recall it. This overload increases stress and reduces the quality of decisions as irrelevant details distract from key insights. Filtering mechanisms such as attention focus and heuristics are our natural defenses but are easily overwhelmed by modern data volume. In complex systems, unfiltered information floods these limited channels, resulting in noise dominance. Financial traders bombarded with conflicting real-time indicators may make poorer investment decisions, like trying to drink from a fire hose when you only need a sip. The DIKW pyramid conceptualizes the transformation from raw data to wisdom. Data are raw facts. Information organizes data. Knowledge contextualizes information. Wisdom applies knowledge for judgment. With excessive data, the transitions between these layers can become bottlenecked, breaking the pyramid's integrity. Without efficient data reduction and meaning extraction, higher level insights collapse under the weight of unprocessed information. The scientists with petabytes of genomic data, but lacking proper analysis pipelines, cannot derive actionable medical insights. Like having a mountain of puzzle pieces, but no picture to guide assembly. AI and machine learning models depend on large datasets, but also risk being misled by irrelevant or noisy inputs. Overfitting, a model learning noise instead of patterns, is a direct manifestation of the information paradox in algorithms. Large datasets require careful curation, feature selection, and bias mitigation to be useful. Inadequate preprocessing can cause models to reinforce false correlations or produce unreliable predictions. Thus, more data is not automatically better data without robust analytical frameworks. An AI trained on social media data might incorrectly identify irrelevant trends due to unfiltered noise and bias, like a chef using every ingredient in the pantry without a recipe, ending up with an inedible dish. Effective information depends on the signal-to-noise ratio, SNR, not the total volume of data. A higher SNR indicates that the useful signal stands out clearly from the background noise. As data volume grows without careful design, noise often increases faster than the signal. This makes detecting true patterns exponentially harder, even as storage and transmission capabilities advance. The paradox arises because the human and algorithmic ability to distinguish signal deteriorates with low SNR. Satellite imagery analysts often drown in data when clouds or irrelevant features obscure meaningful signals, like searching for a faint star in a sky flooded with city lights. Constant exposure to large information streams can lead to information fatigue syndrome, IFS, characterized by exhaustion, decision avoidance, and reduced critical thinking. IFS is now a recognized risk among knowledge workers, healthcare professionals, and educators. As cognitive resources deplete, people resort to simplistic heuristics or completely disengage, negating the benefit of additional data. This not only affects productivity, but can also compromise ethical or safety-critical judgments. Preventing IFS requires thoughtful information design and periodic cognitive breaks. Corporate executives bombarded with endless reports may ultimately rely on gut feeling rather than evidence-based decisions, like trying to swim continuously in a riptide, eventually leading to complete exhaustion and surrender. Scientific fields increasingly face a flood of publications, data sets, and preprints. Researchers struggle to stay updated, leading to missed breakthroughs or duplication of efforts. Meta-analyses and systematic reviews help, but their effectiveness diminishes if input data quality and filtering are poor. Furthermore, conflicting studies create data smog, obscuring consensus and delaying policy or clinical translation. The paradox threatens scientific progress by burying signals in an avalanche of partial or contradictory results. During COVID-19, thousands of conflicting preprints made it difficult to establish clear treatment protocols rapidly, like searching for a lighthouse signal during a blizzard of flashing lights. Decision makers and governments and corporations are increasingly overwhelmed by data-driven dashboards, scenario analyses, and real-time reports. Policy paralysis can occur when leaders hesitate amid conflicting information, fearing unintended consequences. Over-reliance on big data may also overshadow local knowledge or experiential insights that are crucial in crises. Thus, governance in the data era requires selective simplification and robust sense-making strategies. Economies that fail to manage information overload risk losing agility and competitive edge. Pandemic response teams delayed lockdown decisions due to conflicting mobility and transmission models, like trying to steer a ship while hundreds of contradictory maps are thrown onto the navigation table. Addressing this paradox involves prioritizing quality over quantity, integrating intelligent filtering systems, and strengthening critical interpretation skills. AI tools must be designed to highlight relevant insights and explainable decisions rather than just aggregate data. Human-centered design principles can reduce cognitive load and enable actionable knowledge rather than mere data exposure. Educational systems should emphasize data literacy and discernment as core skills, Ultimately, taming the paradox transforms data abundance from a burden into a strategic asset. Some hospitals now use AI triage systems that summarize critical patient data into concise dashboards for doctors, like converting a roaring waterfall into a calm, focused stream to irrigate a field effectively.